Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. Today on the bench I have a Harman Kardon HK560 DC amplifier receiver. I love working on these. They're nice and simple, and then when you're done, the end product sounds fantastic. This one is a client unit, and he brought it. He wants the full meal deal on it, and he told me one channel was out, but I was looking through the grill at the top here. There's fuses and stuff. I don't see any blown fuses, so I kind of have my doubts about that channel being out. Might be just a bad switch or something. Who knows? That's usually what it ends up being, is just a bad switch, like a tape monitor switch or something that needs cleaning. So we're going to go through and do the full meal deal. I'm going to do things a little different this time. What I've done is I've gone through my notes and I've assembled a capacitor kit for this thing and got all the values and numbers of what I need here. And I'm going to try with this assembled capacitor kit. I already know that these mini filter caps are too big. They might not fit. I have to scale those down a bit. But it's a trial run just to see how it goes. And if there's any interest in this, I might make these kits available to my viewers at a reasonable cost. I don't want to get in the business of mail order shipping things and selling stuff, but if it helps somebody out, I don't mind doing that. So I'm going to put this capacitor kit in it, and we're going to see how it goes, and we're going to troubleshoot this, see if we can get that one channel going. We've seen the 560 before. I've had one on the channel already, so I'm not going to go through all the features and all that. I think we can skip that. And let's just take the top off and have a look inside. Alright, off comes the lid. Nice clean lid inside. Looks very nice and clean inside. Hasn't seen much use. Let me spin this so you can have a better look. Spin it this way. Yeah, it's very clean. I'm really surprised. Usually you don't see them clean like this. And like I said, these two fuses are intact. So if it was one channel or the other that blew up and shorted output devices, this fuse would be gone. So I have a feeling this amplifier works on both channels, no problem. Wow, what a clean unit. Maybe this one's not a good candidate for a cap kit. Might have to just think about that one. It's got the blue TKs in it, not the green TKs. I don't know how those blue TKs hold up. There was something crunchy with the down cord. Oh yeah, I see. This is hitting the printed circuit board down below there. So this needs to be shoved back in. It was making a funny noise when I was tuning, but then as soon as I rotate it a few times, it comes back out again. It wants to migrate out. Alright, let's pull the bottom off. Alright, either somebody's cleaned this already once, or it's a time capsule, because I pulled the bottom plate off and there's absolutely no dust on here whatsoever. So I think maybe somebody took it apart and cleaned it. But it looks really pristine. This fuse is intact. Everything looks good on the bottom of the board so far. I haven't really looked closely at it, but let's hook it up and test it and make sure we have all functions. Okay, got the bottom off. Speakers are connected on system 2. They're turned off right now. Let's turn this on. I think you can see, ooh, that's not good. Keeps rising in power. 50 watts. So maybe we do have a serious problem here. I wanted to measure let's measure DC offset on system 1. Let's turn our voltmeter on. See the right channel. Okay, volts. Here's the right channel. Let's turn it on. Speakers on. Okay, everything's on. Yes, okay, so here we go. 20 watts. And then, yeah, we got 1.5 volts. Something wrong with the power amplifier. Let's try this other channel. Okay. You notice when I turn the power on, it has a low value, about 20 watts or 25 watts. And then when the amplifiers turn on, there's this delay. Notice how the wattage climbs. We'll do it one more time here. I don't want to leave it on too long. Okay, we're going to see if we have DC offset on the other channel. Volt and a half. See, that climbs awfully fast. 52 watts. Shouldn't be 52 watts. Something's wrong here. Okay, we got some troubleshooting to do. One thing I'm going to do is I'm going to let's see here. These transistors hot. These ones are a little warm. I'm going to get my voltmeter out and I'm going to measure the bias current on each amplifier and see if one of them is drawing heavy current. I don't know which one it is, and that'll pinpoint to us what's going on here. Alrighty, according to the service manual, we should have 33 millivolts across both emitter resistors. So I've got my voltmeter across both emitter resistors. Let's power up, and then we'll see the delay before the amplifiers come alive, and then we'll see what kind of bias we have here. Okay, 40, 43, it's climbing awfully fast. 50. I'm just wondering if we turn this down. Yeah, but we're still at 52 watts here. So let's go after the other channel now. Okay, we're now on the other channel. Let's turn the power on. Let's see how this one looks. Still high. Why we still have 50 watts coming out of here is we shouldn't have that high of power. Not on this little amplifier. So I have a feeling there's still something wrong. Something's getting hot. Let's try the speakers. Okay, that's the right channel. Nothing in the left.
In fact, if you're don't die. 100.
Okay, so we're not getting any stereo.
Leave it to me.
No stereo, no left channel. Okay, I got a 440 hertz tone going in. Let's turn the power back on. And see what we got here. I've got signal in both amplifiers. So I'm taking I'm picking off the signal right between the two emitter resistors, which is the center point of the Class AB transistors. So, and from what I can see here, I'll show you. Okay, there's. Let me turn the speakers off. Turning it up. We have both channels working. So let's turn it up. Got no load on it right now. One channel's a little quieter than the other. And you can see that. When I lay them on top of each other, a little bit of phase difference between the two, and there is a little bit less on the top trace. But everything's working here. Let me see. Change my probes. Let's turn it up. There's clipping with no load. But I was hearing distortion, and that was on very low. I don't see any distortion. $55 watts. Something's wrong here. What I'm going to do now is I'm just going to go through and put the cap kit in, and I'm going to go through and recap this. And then we'll return and we'll see how it's working. Seems to be working fine as it is right now. Everything sounds good, and we have no FM stereo. I can tune. The lamp is working.
Fort Saskatchewan reminds you to keep your baby's car seat rear facing until they surpass the
There's
weight
just
or
no
height limit of the
stereo.
rear After car seats come booster seats. Read your booster seats. It will clearly state weight and height limits.
Oh, why is it stuck? This thing. Okay. So it's mostly working, except for the FM stereo. Okay, first up is these electrolytics, these main filter caps. Now I specified 10,000 microfarad at 50 volt, but that's overkill. The originals are 4700, and these won't fit anyways. They're too big diameter. These are 30 millimeters, I believe. Yes, and the originals are 25 millimeter in diameter. These will work. These are 6800 at 50 volt, and they are 23 millimeters at 22. So they'll fit in there perfect. We won't get rid of these because we're not going to use them. Now let's pull out the originals and see how bad they are, or how good they are. Okay, a little bit of glue there. Here's the originals, 4700 at 15. Let's see what the value is. And they are down to about 4,400, which ain't bad. They're not bad, I guess. ESR is 23 milliohms. Pull out the other ones and test them as well. Okay, they measured all the originals. They're between 4200 and 4900 microfarad. I'm going to replace them with these. And these measure out at around 6100. These are 6800, but they're down a little bit too. They're brand new. And they have 2021 date codes on them, so they're fresh. Alright, so I'll make the changes on my list here, and then we'll continue on. Now, this is the rest of the cap kit. Just going to go through and install all these, and then we'll see how it goes. One of the things I don't like about these series of HKs is the front panel and their controls, and everything's jammed in here. Pretty much have to disassemble everything. I think for this one, what I'm going to do is I'm going to take the dial string off and just put it safely out of the way here, because I got a lot of stuff going on here. And all these switches I want to clean, and I'm going to get underneath and change all those caps. There's a switch here I want to pull out. So I think just take the dial string off, and it's not that hard. If I can find my, actually I'll just use a pair of needle nose. So what you do is just grab the end and unhook it from the spring. Okay. All right. And then we have our diagram to put it back together. So we unwrap it here. Three or four wraps on that. Take this down, out. And what I can do, I'll just put this in a plastic bag and tape it up here so it's just out of the way. See, yeah, a little bit of pain, take it all off, but you get a lot of gain out of it. You got full access to all these pots, switches. You can now reach all these caps, and makes it that much easier. Just a little extra work. Not sure if you can see this. This is, let's see, where are we here? This is a transistor, and you can see the top of the transistor right here. What this is this is the bias tracking transistor. It's one that's attached to the heatsink, and it's got three cracks around there. And you can see those rings. Not very good at zooming in, but I don't think this this was a problem until recently. This here, I don't think it affected the amplifier because I don't think it's completely broken. But we are going to get to the bottom of what's going on with this thing. Now, something I normally don't do, probably I should do more often, is I want to remove all the transistors from the power amplifier section, and I want to check, see if they have a good gain, if they're strong, or if they're failing. For whatever reason, these amplifiers are drawing a lot of current and consuming a lot of power, so I just want to get to the bottom of it. Maybe I have bad transistors in here too. So I'm going to get started. I'm going to start pulling all these transistors out and testing them, putting them back in if they're good, replacing them if they're not, including the power transistors and the bias tracking transistor there at the bottom. And go through this. Recapping's been done. That went well. I'll talk more about that later at the end. And yeah, but right now I want to focus on these transistors. Alright, so I just went through and tested all these transistors. I yanked them out of circuit and tested them for beta. They're all good except for one, and I kind of suspected it would be one of these transistors. So this one here is a 2SC1472, and that's a Darlington NPN transistor. Has a gain of minimum 2000 HFE, and I took this one out and measured it. It measured around 2400 on the gain. Took this one out and measured it. It measured down around 1300. So it is below minimum spec, and this one's failed. This one here, this is the square body TO92 package with the black leg syndrome. So looks like these ones are fail prone too. This is 2SC1472. So I added them to my naughty list. Problem is, these are Darlington transistors, and they're not, I don't really, well, without digging through my entire inventory, I don't know what's a Darlington, what's not. So what I've done is I ordered a variety of Darlingtons, and they're going to be here tomorrow, and I'm going to check and see which one's the best fit. I think I ordered 4 different types, and yeah, it just has to have a high gain. You know, it's in the bias spreader circuit, and this does the thermal tracking for the bias circuit. So it's not really demanding, it's not high frequency, it's not high current, it's not high power. It's just there to do the business of tracking. So tomorrow when my order comes in, I'll see which is the best fit, and then I'll tell you guys which one I selected. All the other transistors are okay, except for 2SA844, sorry. I removed that and replaced it with 2SA992s, and I'm going to do that for the rest of the unit when my transistors come in. I got an order in right now, and I'm low on transistors actually, so I ordered a whole bunch. Got 400 coming in, and yeah, we're going to replace all these ones that are on the naughty list. There's a whole bunch of them. I think there's like 20 or 30 of them. Okay, I had to soak these transistors in like brake fluid for about an hour because the silicone grease is like petrified. You just have to scrape it off with my fingernail. It does not wipe. So once I clean them up, they look good. See, look at this. This doesn't come off. I have to fight with it. Same thing with this. I had to fight with the cleaning that. So, but it's good now. Okay, update time. Lots going on here, so lots to cover. So I'm done with the switches and pots. Everything's back together, soldered in place. I cleaned up these top boards. I'm pretty much prepared to put the front chassis plate back on. So that's going to happen today. I also removed the power devices and heatsink, cleaned that all up, and get this prepped for reassembly. Now we had 2 transistors here. One of them or both of them have failed. They're Darlingtons, so I purchased 4 different types. And out of the 4 different types, only one seems suitable. So this is a KSP13 ACT. This is a Darlington transistor from onsemi, and this one has a gain of about 22,000, which is a little too high for my liking, so I'm going to put that one aside. Another one I purchased is this is a HK560, and this one has a HFE of 35,000. So that's not suitable. That's way too high. This one here is from Diodes Incorporated. This is a ZTX614. It's a common Darlington transistor, 100 volts, 0.8 amps. It's a very capable transistor, but it has a gain of 20,000. So I bypassed that one. And then I purchased from onsemi. This is a Motorola plastic silicone, MPSA 29, and it's got a HFE of 15,000. This is the one I'm going to go with. Problem is, all 4 of these transistors have incorrect basing or incorrect lead outputs. This one's emitter base collector, and I need emitter collector base. So I'm going to have to swap 2 of the pins. Normally I just use my Teflon sleeving, but this is way too stiff to do that. It's really rigid, so I'm not going to use that. So, but I've also purchased this online, and this works really good for me for doing protection of leads and stuff. This is silicone tubing, and it's very super flexible, as you can see. And I'll cut a couple short lengths of this, and then we'll swap those two pins and then insert. I'm going to put transistors, new transistors in both positions so that they're equal. And then we can drop the heatsink in with the transistors. Transistors are already mounted and heat sinked. They're all here and they're in place, ready to go. So, lots of assembly today. Yeah, just basically just putting it all back together, and then I'll bring you back in. Okay, last thing I want to do before I put the heatsink and power transistors back in the board here, I want to install these thermal tracking transistors. This is the MPSA 29, yeah, and I have the silicone sleeving on it. You can see it's very flexible. I don't know if I told you this before, but you can buy this sleeving on, well, it's actually food grade silicone tubing, and you can buy it on AliExpress. It's like the smallest stuff to 1 millimeter or half millimeter or whatever it is. I think this is this. Yeah, this is the smallest, half millimeter in internal diameter, 1 millimeter outside diameter. I think this is like $1 a meter. You can buy this stuff super cheap and use it as sleeving, and it's silicone, like it's really flexible and heat resistant too. So what we got to do is we have to swap the base, which is the center, for the outside. So I'm just going to bend this, and then I'll bend this one into the center. You can see how they cross, and you don't want them touching. That's why the sleeving's there, obviously. Okay, so we now have emitter collector base, and it should match up with the board. Emitter collector base. I'll just drop this in place here. If I can get it. Get them in line better, it might help. Okay. And what I'll do is I'll solder that down in place. I might have the leads too long. I might just push it down. Push it down and solder it so it's about that high off the board. Because once we drop the heatsink in place, I'm just going to fold this down onto the heatsink. A little dab of compound on the front face of it so it makes thermal contact. Fold it down, and then there's a spring clip that holds the transistor down onto the aluminum. So, and you know what? I don't even know if this is going to work, if these transistors will work. I'm assuming they will. I won't find out until we do our first initial test. Let's try this again. Let's bend this one out of the way. Bend this one into the center. And there's the other one. So I'll put that one over here. This one goes here. Okay. I'll solder those in place. Now I think what I'm going to do before I put the heatsink back in is I'm going to restring the dial cord, because it gives me a lot of room here. Once you put the heatsink in, there's a wall here, and it's hard to get your hand in. But now it's all open and easy. I can do it. So I'll probably restring the dial string and get that working, and then we'll put the heatsink back in. Okay, let's see how we can do this in one shot with no retakes. This one's not that bad, I don't think. It's pretty simple for a restringing. Is we have the original string, it's not cut, we don't have to make a new one. All we got to do is hook this end onto this spring, and that might be a little bit tricky because when I pulled it off it was tight. So let me just poke a thing through here, make sure our hole is open, and enlarge it a bit. Okay, now we got a string. Let's make sure there's no knots in it. It's all good. Okay. So I'm going to put the diagram up on the screen so you can see it and follow along. I'm going to try this. Now the first step is they want us to have the tuning capacitor in closed position. So that's fully this way. And then the first step is to wrap from here around the bottom and out. The second step is this pulley here. The third is this pulley. And then our dial pointer gets put on there, and then we go, this is 5 and 6 down here on these two pulleys. Get it around that corner. Helps if you have might help if you have a hook tool like this, where you got a hook on one side, and you can grab it and feed it into the corner. It's not cooperating. There we go. You feed it into the corner and get it over that pulley. There. 5 and 6. Now you notice I put the light bar in just because taking the light bar out and putting it in, it has all these sharp edges, and I just didn't want to cut the string. So where are we here? 7. We go in the bottom of the tuning knob. This I re-greased so it spins nice. So we go in the bottom, 1, 2, 3, out the bottom, onto this one, back over to the top of our tuning drum. Now we got to get 2 wraps on this somehow. So I'm going to use whatever means necessary to get this around the bottom of it. It's really, I can use my hook tool again. Here's one, and the other. Probably what I'm going to do is hook this on now, and then bend this back. Oops. This is where the hook tool comes in. And let me zoom in and I'll show you how I'm doing this. So I got it coming from the top, going under, around, twice. I got it hooked on the spring. So I'm just going to hold this part and tighten it up. Tighten this up just to take the slack out of the system. Okay. Now what's left to do is just bend the spring. Well, let's try this first. Let's get this string underneath. It's not cooperating. Let's try it from here. This might work. This is working. Okay. So we want to get this over the drum. Here it is. Okay. So we've got it strung. Let's run it through a couple of cycles of back and forth. Nothing's binding, nothing's dragging, nothing's cutting. This gets hooked on here. This string is catching on the spring. Here it went twink. So I'm just going to, how am I going to fix this? Because eventually it'll cut, it's the brass. Hang on, let me show you. Run it down this way, and if I go this way, this brass thing catches on the string. Eventually that'll cut through, so I'm going to have to do something about that. Might have to just crush this side down a bit. I don't know if that's going to work. It's missing it now. Okay, we're done. We're done. So, dial string's back on. Everything's good. I got 3 wraps. If you put 4 wraps on this, I believe that you won't be able to get this spring to engage. The string will be too short. Now another problem I'm having here is this. The drum wants to walk out of the tuning capacitor, and see, it wants to drag on the printed circuit board here, and it's catching on our eyelet. Now I don't know how to get that to stay in, because when I push it in and rotate it back and forth, it wants to walk out again. See? And then eventually it walks out to the point where it's dragging on the other printed circuit board. Right there. That's fully open. Fully closed. It gets hung up halfway through the scale. So I don't know what I'm going to do about that. It seems I could try putting an E-clip in inside there to hold the shaft from coming out, but I don't know if that's, there's no groove in it for the E-clip to sit in, so it would just be a purely friction fit. Don't know about this. I wonder if I move the spring in and cement it there, that way it won't drag. But then it'll just get caught up on this drum anyway. Okay, one thing I want to take care of is this shaft here that keeps working its way out. See how much play I have in this shaft. And if it wasn't for this PC board sitting here, this thing would just fall out. That's not right. I don't think it should be like that. I don't know why it does that. It's really quite annoying. And if I adjust the tuning dial, you can see how it walks out on its own. All you have to do is go up and down the band once, and it's completely out, and then it locks up. It doesn't move because it's hitting on the other printed circuit board. And you fix it, you have to press back in. So what am I going to do? I have one idea. I was thinking of taking a E-clip and putting it in behind this gear. Let's see, we push this in, push this out, and I can see a little bit of shaft here. There's no groove cut in it for an E-clip, but I'm going to stick one on there anyways, and if I can just get it to bite on the shaft, maybe that'll prevent it from walking out. So I'm going to do that. I'm going to see if I can get that clipped on that shaft. Okay, I put that E-clip in there. It was actually a lot easier than I thought. It just snapped in, and it seems to be the right size too, because I went up and down the scale about 10 times here, and it's holding the shaft in. It's not walking its way out like it was before. I don't know if you can see the E-clip in there. It's really kind of dark, but if it is in there, you can see it. It's just a little little, maybe not from the camera angle, but, and it's keeping it together. Going back and forth here a few times, and it just doesn't seem to want to work out anymore. So I'm going to call that fixed. Another thing is the string is about 1 millimeter away from this sheet metal edge here. I'm just going to try loosening the light bar, and maybe I can shift it down a little bit just so it's away. No, that's as far as it goes. Okay. Tighten these back down. Next I'll loosen this, and I'll pull the pulley up a bit to give it more space and tighten it down. It's not touching there, but it's awfully close. I think it'll be alright. Alright, heat sink only goes in one way. There's a hole down here at the bottom corner. That's for this TO220 device, the voltage regulator. And just got to put this in. Now what I did is I have these 2 transistors standing upright, and I put a little dab of heatsink compound on the face. And then I'm going to put this in. Just be careful I don't smear it. And it should just, if my holes line up on the devices, I think it will. Except that one, you have to nudge them in. There we go, drops right in. This side looks like it's in. Okay. So what we got is 2 screws from the bottom coming up, and then we have 4 screws from the top going down, 2 on each end. These ones on the ends are self-tappers. The ones in the middle are machine thread. Just put this one in here to hold it. Put this one in here to hold it, and then I'll flip it over and I'll put those 2 machine screws in and snug them down. That'll pull it down to the board. Snug these 2 down. Don't solder any transistors in until all your bolts are tight and secure. Otherwise you'll crack traces. So next thing we need to do is put these clips on. So we have to fold these transistors down onto this heatsink. So I'm going to put a little thing here just to lever it. Actually, I wonder if I could do it from here. I'm going to get... not long enough. Let me see here. This screwdriver here. I wonder if I can just push this over. Something like that. Okay. I think that might be good. Now, you see our little spring clip. It's just a piece of spring metal. Put this on. Just lay it on here. Kind of fussy because you don't have room to put your hand in. Okay, now we need a screw. Where did I put my screws? Yeah, of course. Okay, starter screw. this thing back up on top. There we go. Okay, torque it down, and I can see the heatsink compound squeezing out from this side. So that's making physical contact. That's what we want. Now our leads should be insulated, but we can spread them out. You can test with an ohmmeter from the other side, make sure those 3 leads are not shorted to either the heatsink or each other. Otherwise it'll grenade your amplifier and turn it on. So let's just make sure it's tight. Okay, I'll do the other side and we're done. Once everything's done, we can solder these in. Let's see here. Now you got to test for shorts between the devices, the output devices, and the heatsink. So make sure that your insulators are good. And if that's all good, you should be okay. I'll clean all the flux up on this board. I still haven't finished cleaning flux. Got it quite a bit here yet. I did clean the tuner and it's looking good, but this board is still dirty. The last thing we need to do is heat sink this one. This is a regulator transistor, it goes to the heat sink. So what they had is they had a plastic screw. You can see it's made of plastic, and a micro washer. I don't like these plastic screws because over time they get really brittle and they can just snap. And you can't put much torque on them either. They're just really light torque on them to get them to tighten down, but not happy with those. So I usually just replace it with a regular steel screw and use a shoulder washer, insulating washer, like this. And we'll use that on there. And we'll also, instead of using a mica, we'll use a sill pad. And I'll just assemble that. It's going to be hard to do on the camera, so I'll put that together and get that set. Okay, at this point, electrically everything's done. I still have to dress the cabling and do some wire wraps or wire strapping. Everything's put together except for front panel, and the meter has to be soldered in. That's the last thing that needs to be done. But I'll work on this, but we are ready for testing. Okay, let's set our amplifier up. We got DC balance and bias to set up, so let's turn it on. Okay, got the voltmeter. Let's connect our voltmeter across from ground. Let me see if I can find a good ground here somewhere. Come on. Okay. And we'll go to one of these speaker circuit breakers. There we go. That's before the switches. That's before the output. So let's turn it on. Let's watch our watts climb up. 56, and then it drops down to 27. Amplifiers kick in. It comes back up to about 35. And here's our DC offset. It's going to settle. We're doing, let's see, we're doing purple now, which is this channel here on this side. So I'm just going to let that settle a bit and then adjust this for 0. Negative. If I turn it clockwise, it goes more. counterclockwise, it goes up. I might have my probes. No, we got a negative voltage on the speaker, so probes are done right. Just gonna keep going. There we go. Now we're into positive. Pretty damn good. Okay, let's do the other channel. If I can get this on, it doesn't. These don't hook on very good. Okay, there we go. 18. This one goes opposite. If I turn it clockwise, it goes up. Get it down as close. I can come and fiddle with this later. Don't waste your time watching me zero a meter. Okay, now we're done with that. Now I don't know if I've ever mentioned this before on the channel. It's probably a really good tip for all you guys that maybe some of you are aware. A lot of you probably are aware of this, but some of you aren't. A really easy way to check if you have DC on your coming out of your power amplifier going to your speakers is turn your speakers off. And then if you click the speaker on, listen for a pop or a click. The louder the pop or click or thump, the more DC you'll have. If it's completely silent, you probably have no DC at all. Now I can hear a little pop in the left channel. It's so quiet. I don't know if you guys can hear that. But it's at such a low level, it's not really anything to worry about. But once this warms up and I've finished I'll go back and I'll check the DC offset one more time. But that's an easy way to check. And you don't need any special tools. You just need a pair of speakers in your ears. And you just push the button in and out. And if you hear that clicking, popping, you know there's something up. Okay, I don't know if you noticed, but our power consumption went down to 41 watts. I remember when we first started this video, we were up over 50. So whatever we did made an improvement. But we're going to do DC balance, or DC offset right now. Or sorry, we're going to do DC bias. So the manual states you connect the probes from the emitter of one transistor to the emitter of the other. Now you could do that down here, but it's high danger of shorting it out and risk damaging these transistors. You can do it across both emitter resistors. They're asking for 33 millivolts over both emitter resistors. Let's see if we can connect this up. That's the problem with these. I can't get my big hand in here. Some people it's probably no problem. There we go. Okay, one more. Okay, we got 21, which is a little bit low. Let's turn it up to 33. I'll leave it at 32 for now, let it warm up. Do the other channel. Right now we got helicopters circling our house because apparently in our neighborhood we have a gunman loose and they're looking for him. And we're told to stay indoors and be safe. So that's what I'm doing. I'm working on this afternoon. I wanted to be outside. It's a beautiful day, but can't go outside because somebody's in a bad mood. And okay, let's turn this up. Turn it the other way. I'm getting close. Okay, I'm going to leave it right about here. Just going to let this thing idle. It seems to be consuming a lot of current though. It's better than what it was, but it's high. I don't think it should be that high. I've seen these receivers, it should be down around the mid 30s or low 30s for wattage consumption. So, but I'll let this go. I think our choice for Darlington transistors is working fine. We'll see how it tracks how the biasing tracks with once it warms up, if it stays stable or if it climbs or goes down. We'll see how that goes. I'll just monitor this for a while. That helicopter with the white with the blue tail, red stripe in the middle, that's RCMP. I don't know if you can see that, but just on the tip of that roof there's a drone. See a little dot? It's just hanging in the air. And if I go up here, here's our RCMP. He's probably mad at me for standing out here. Alright, so we are ready to do a power test. I have my load hooked up, scopes hooked up, sig gens hooked up, everything's ready to go. Just need to turn it on. And let's see how this goes. Speakers 1, tones are flat, everything's good. Auxiliary, okay. So I did go back and reset the bias and reset the offset. They drifted. This thing drifts once it warms up, so you have to warm it up before you set it. And it's good now, and it's drawing 39 watts, 40 watts on average. It's a little low. It usually was at 35. I wonder what's going on here, but we have everything running. So let's turn this up. We have both our channels. Let's go up to clipping. Right there. Back it off a little bit. Right to the point where it looks clean. And both channels are tracking pretty well. Right, both here I think. Leave it at that. And then we'll start our timer. And we'll just wait this one out. So 220 watts going in, and we have on the left channel we have 21.54 volts RMS on the output. So I'll let this go for a while and we'll see how this warms up. These Harman Kardon series receivers with this aluminum extrusion heatsink, they're not the best at cooling. They have a lot of surface area, but I've never been impressed with the cooling of these heat sinks, so we're just going to see how this goes for the next few minutes. And I'll shut up now and let it do its thing. Okay, we're at the 6-minute mark, and both sides of this are getting pretty hot. I can't hold my hand on it too long, so it's ouch. See, this one's probably over 60 degrees already. This one, yeah, it's getting, they're both pretty same. So 6 minutes for the endurance test. Let's turn this down. I don't want to blow anything up, which ain't bad, but like I said, I don't think the heat sinking's as good as it could be on these HK receivers. But then this isn't a powerhouse. This is just a great sounding amplifier that you want to listen to at normal levels. You don't want to push this hard, too hard. If you want to push it hard and rock the party, you better off get a better receiver, but this one is for more personal listening. Alright, so I'm going to shut that down. Let's do some other tests. Let it cool for a bit, and we'll do some square wave tests to see how this is. Alright, here we go, 1000 hertz tone. Let's turn up the sensitivity of our scope a little, just to get it. We're not going to go full power here, we're just going to go a few watts. Okay, so what do we have here? This is a bass cut, bass boost, treble cut, treble boost. Oh, we've got quite a range there. Balance control. Tape monitor switches don't do anything. Let's see here. Tone defeat. Yeah, that's better. If we hit tone defeat, it squares up those square waves pretty good. There's a little bit of coloration with the tone defeat out, and I think you could probably null that out with adjustments like this, and then when you hit the tone defeat. So we got the treble at about 11 o'clock position, and that tames it down a little bit. So let's put tone defeat on for now. Subsonic. Doesn't have much effect. Mono. Okay, let's go up in frequency. (10 kilohertz). That's a pretty good looking square wave for 10 kilohertz. No weird ringing or anything. Let's waiting to heart clipping. Okay, let's keep going at frequency. (20 kilohertz). Yeah, we're starting to see the effects of the slew rate. Let's keep going. Right about here, it's starting to really fall apart. That's 47 kilohertz. So it's doing not too bad. Better than most. Yeah. All right, I think this one's gonna sound good. Now, we're still not done with it yet. We still have to fix the FM tuner is not bringing in stereo signals, so we have to figure that one out. So let's do that next. Okay, so I'm gonna go through and do AM, FM alignment. I'm going to do the AM only because I have the test gear out and do it. Might as well just do them both. But the first step in diagnosing any tuner problems is just go through and do the alignment, and that'll tell you if there's a problem in a part of the circuit, or if one area of the circuit's not working, or if it's not responding to adjustment. Then you know that you got a problem. Other obvious things to do, since we had this all apart in pieces, make sure you have the stereo LED in the correct way. If it's in backwards, it won't light up. So I'm going to check that because I've been known to screw that up before. And I'm going to make sure that that's good. And then we're going to go through AM, FM alignment. I'm going to go do the AM first just to make sure the dial scale is accurate and we have maximum sensitivity, and we're going to go through and do the FM as well, and then we'll figure out what's wrong with this tuner. Okay, I've been going through the alignment. AM went well, FM went well, up until the point where I got up to the multiplexer oscillation frequency adjustment. Now, the thing is, when you feed in a signal, and with my signal generator I can feed it an audio tone, modulated audio tone on top of that. I don't have a stereo generator, but what I can do is I can inject a 19 kilohertz tone into the carrier frequency, and I can get it to simulate a stereo station. It would have no modulation, of course, because my test tone is 19 kilohertz, not audio. Connected it all up, did the tried starting the alignment, and it would not lock on stereo until I set that pilot tone up to about 22 kilohertz. Which is about 3 kilohertz off of the 19 kilohertz, what it should be. So they tell you adjust trim pot 301, which is right next to the stereo multiplexer chip. So I did that, and I got it down to about 20 kilohertz. I can't get it to 19. I can show you this right now. I have it set for 19 kilohertz modulation, and let's get the station here. Fairly weak signal, not the greatest signal, but we're locked in. And if I start turning up the frequency of the pilot tone, 19 kilohertz right now, if I keep going up, you'll see it'll lock in. Locks it in 19.9. Go up to 20.8. Now that should be down around 18.5 to 19.5. I have that window where it locks in on 19 kilohertz, but that window is shifted up quite a bit, and I run out of adjustment range on the trim pot. So let's go look and see why it's doing that. Okay, here's a look at the HA11223. It's a multiplex chip. Here's our voltage controlled oscillator, 76 kilohertz. I think it's an internal oscillator, and it's controlled by pin 16, and I think adjusting a voltage on this pin will control the frequency of that oscillator, and then it flip-flops down to 38 kilohertz, flip-flop to 19 kilohertz, 90 degrees out of phase, another flip-flop for 19 kilohertz output. That's where they derive the 19 kilohertz from, but we're not getting 76 kilohertz, we're getting something like 80 kilohertz on this oscillator, and we need to turn it down to 76 to get the right frequency. So let's look at the circuit itself and see what we can do. Something's beeping. Okay, here's our chip, the HA11223. Pin 16 is right here, and it goes to a C303, 1000 picofarad capacitor, R304, 33K to another capacitor of 2200, and then we have our adjustment right here, a 3.3K trim pot and a 5.6K fixed resistor. So this circuit here should be tuning that 76 kilohertz oscillator. So we're going to snoop around here and see if we can find anything wrong with any of these components, because we are really far off. So the first cap I pull out is 1000 picofarad styrene, and it's measuring 2% out. It's actually drifting a bit too. If I heat it up, it changes. Drifted a little bit there because it was usually down around 1.5% out, but now it's drifted up to 2%. So maybe this cap is faulty, I don't know. But that shouldn't be, it shouldn't put us that far out. Okay, VR301 is right here, and it is a 3.3K, and it measures 3K, so it's open, or it's on the high end of its rotation. And it's in series with a 5.6K resistor, so here's the resistor, 5.57, so altogether we have 8.66, and it's not enough. I think I need to raise this up higher to get that oscillator to run at a lower frequency. I got one more cap to pull out, let's check it. Okay, here's cap 304, and it's a 2200 picofarad styrene. Let's check it. A little high, 22.5. A little bit off. But then, I don't know, these are J, it should be within 5 or 10% for sure. And that is within tolerance. So I don't think that's it. So what I'm going to do is I'm going to remove this 5.6K resistor and replace it with a 6.8K, and that goes right here, R303. And that should buy me enough range to adjust this trim pot to get the oscillator up to 76 kilohertz, or down to 76 kilohertz. Okay, so I changed that resistor. Let's see what we can adjust it to this time. I got a signal going in, 98 kilohertz. And you should be able to see it up on the screen there. And we're feeding it a 4 kilohertz tone right now. And I can adjust that. 1 kilohertz. So let's go up to 19 kilohertz and see if it locks in, or where it locks in. Oh, it's already locked in at 18. Okay. So, let's take it up slowly. We hear the background hiss. So it locks in at 17.7. Kicks out at 18.7. So we need to adjust this to 19. So let me get my screwdriver. And let's adjust this. So from about there to there is my range. Let's set it halfway. And then I'll check it. Go down. So we got 18.3 on the low end. 19.4 on the high end. Let's give it a little bit more. Let's take it to about there. That should be the high end, so I'm turning it counterclockwise. There. Right there. Alright. That's good. It's centered right around 19 kilohertz. And if you look, let me shut this off. If you look at my signal, if you look at my frequency counter, it's right around 76 kilohertz, a little bit high, but I'm happy with that as long as it locks into stereo station. So let's test it. Shut off the signal generator. Stereo signals.
Countdown.
It has no problem locking on the stations down.
Some seashells.
Loves good times.
Sounds good. Alright. So I don't know what to think about the cap kit thing. You guys tell me what you guys think about having me make up a cap kit for this thing and making it available for you. I know there's one guy on eBay that is selling them. He's making good profit too. What is he asking for the 560? He's asking $165 US plus another 20 or 30 bucks to ship. eBay cap kit sells for US. Yeah, so I don't know if there's a demand for it, I'll do it. But if there's not the demand, I guess we'll have to figure out something else. You guys tell me what you think. I suppose a cap kit would also need to include all the transistors that are replaced, because a lot of those transistors really shouldn't be in these things anymore. They're at that age where they're gonna start failing, as we saw with the Darlington transistors there. But make a cap kit up with transistors. I don't know what costs are, but it certainly wouldn't be $165. It would be a lot less. I'm thinking maybe 1/4 of that price, or 1/3. But I'm not making any promises right now because I haven't crunched the numbers. So another thing I could probably put in there is the fuse style lamps. 6 of those. 8. What do we got here? 28 transistors and 6 lamps. That's going to add to the cost of the cap kit. So It's not something I want to get into either, is making cap kits, because they can be a pain too. Getting all the different types of caps you need and the right quantities, and then you have to deal with the variations in models. So I just thought, just putting it out there, thinking out loud. So you guys tell me what you think. Okay, that's going to end this one here. Happy with the way it turned out. I am going to put this lid back on and finish this up. I'm going to listen to this for a couple weeks, see how it sounds. One thing I like about these receivers is the great sound that they deliver, and it's a really good price point too for these. You can pick these up cheap, and if they're dialed in right, they sound fantastic. So that's it for this one. I'm gonna leave it here. Thanks for watching, and we'll see you on the next one. Take care.